Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 12, Section 9. And in this video, we're going to be specifically looking at combinations, but real quick, I want to touch upon permutations again really quick. In the previous video on permutations, I might have mentioned it, but permutations are basically just finding all the different outcomes. It's the same process we took in Chapter 12, Section 8, counting outcomes. Where if you have a permutation of 5 things taken 2 at a time, you have option 1 and option 2 here, and option 1 is going to have 5 choices. After that, you've got 4 choices left for option 2, and so you would end up doing the 5 choices times the 4 choices, and that'll get you a total of 20 possible outcomes for those 2 positions. Remember, we talked about how this might be president. Choice 1 might be president and then vice president. So there's 20 different possible outcomes for the president-vice president mix. Now, with a combination, we talked about how in a combination, order doesn't matter. So the example we gave last time, was if you were trying to choose colors for your school flag, and let's say one person chose green and blue, and another person chose. So one person chose green and blue for the school flag colors, another person chose blue and green. In this case, order doesn't matter because regardless, your flag is going to be blue and green or green and blue. It's going to have the same colors on it. So order didn't really change the outcome of anything. So what you would do in this situation, if you were counting combinations, you would take one of these and you would basically cross them out and they wouldn't count. So now if you're talking about permutations, this would count as 2 permutations, but if you're talking about combinations, it only counts as 1. Because with permutations, order matters. Okay, so this would be 1 permutation, this would be a second permutation. With combination, order doesn't matter, so GB is the same thing as BG, so you can't count it twice. And so how do you go about finding the combinations? How do you weed out all of those doubles and triples that appear that shouldn't count? All those things that shouldn't count, how do you find them? Well, there's a really simple way to do it. Just like with permutations, basically, if you have 5 things taken 2 at a time, you do 5 times 4. If they were taken 3 at a time, you would do 5 times 4 times 3. You basically count down from the number. If 5 is the number of things being taken, and then basically I multiply down like this, because with each choice, I have 1 less element to choose from. So the example we gave, I had 5 people to choose from for president, then I had 4 people to choose from for vice after that, and then I had 3 people to choose for treasurer. But with a combination, order is not important. So we need to find a way to weed out all of those doubles. So let's say there were 5 colors. Let's say we had red, blue, green, yellow, and purple. Okay? The first thing you would do with a combination, and what I'm going to show you right now is kind of the longer method that will help you understand the shortcut. Okay, so the first thing you would do is we're taking things 2 at a time. So I would take red, and I'm going to match it up. I'm going to go red, blue. So I'm going to find all the different permutations. And I'm going to actually reduce. I'm going to make this I'm going to take 3 things 2 at a time just because it'll make this part simpler. So I'm going to take red, blue, red, green. And I'm going to go blue, red, blue, green, and then I'm going to go green, blue, and green, red. And those are all the different permutations for these 3 colors. 3 colors taken 2 at a time. So here's my 3 colors. Here are all the possible sets of 2 or permutations of 2 colors that I could have. And so now if I wanted to find the combinations, how many combinations are there? So there would be a big C out here. If I wanted to find how many combinations there were, I would I'd say, okay, here's red blue, and here's blue red. Blue red doesn't count because it's the same thing as red blue. Here's red green. Here's green red. Green red doesn't count. It's the same thing as red green. Here's green blue. Blue green doesn't count. And so there's a total of 3 combinations in this case. Now, just as a heads up, just because the number of combinations is equal to the number of things taken, that does not mean that's always true. Most of the time this is not true. Okay? Most of the time the number of combinations is not equal to this first number in the parentheses. That's just a coincidence. Okay? So that's the long way to do it. Now, obviously that's not going to be very feasible or viable if the number of combinations is like 30 or 50 or 100 or 1,000. There's got to be a simpler way to find it, other than having to write out all of the permutations and then find all of the doubles. Well, there is. Okay, and it looks like this. You take the number of permutations, okay? So you take the permutations, and what you're going to do is you're going to divide the permutations, okay, by how do I word this? You're going to take the number of permutations, and you're going to take this number here, which is the number of things being taken. These are the groups, basically. We're doing groups of 2. And you're going to do what's called the factorial of that number. Factorial, if I was taking 5 factorial, okay, that's what that exclamation means, 5 factorial, I'd be doing 5 times 4 times 3 times 2 times 1. So you just basically you count all the way down and you multiply out. So what I would do is I would take that, I would take the number of permutations, and I would multiply by the grouping number factorialed. So in this case, it would be 2 times 1. Okay? And so you might be looking at me a little funny, kind of scratching your head, being like, well, why does that work? Okay? Well, first let's do this example out. Okay, the number of permutations divided by the grouping number factorial. This is your grouping number right here. Remember, we're taking groups of 2. Okay? So if we take the permutations, we would have to take 3 times 2, and we would get 6 over 2, and we would get 3 combinations. Okay? So here are the permutations on top. And I don't know a better way to describe this number here other than saying that it's the grouping number. It's how many numbers are in a group. So I'm going to call it the grouping number. Okay? And it's the grouping number factorial. So if that number was 3, I'd be doing 3 times 2 times 1. If that number was 4, I'd do 4 times 3 times 2 times 1. And I'll explain why here in just a moment. But this is the shortcut method. This will get you the number of combinations every time, guaranteed. This weans out all of the doubles. Okay. So at this point, I would pause the video and take notes. Try to wait until after I explain why this works before you ask questions, because I think that the explanation will be a lot clearer, and it will make more sense to you as to why this works. I mean, things will start to click a little bit more once I explain this. So why does this work? Okay, what is going on here? Well, what do permutations do? Okay, permutations, which is this top number, okay, the permutation of three things taken 2 at a time is giving you all of the different possible outcomes. It's giving you all the different combinations. So for example, if I have 3 colors, I'm going to just put this here. We got permutations over grouping number factorial. So permutations are going to get you all the possible outcomes, all the different combinations. So if I have red, green, and blue as my options, and they're being taken 2 at a time, the permutations are going to tell me there are 6 different ways to group these 3 numbers 2 at a time. Okay? So in other words, I can take these numbers out like I did before, 2 at a time. Here's red, green. Here's red, blue. Here's green, blue. Here's green, red. And here's blue, green. Here's blue, red. So these are all the different possible ways. There are no other ways. There's no other group of 2 with these 3 letters that I could make. These are all the different groupings I can make with these 3 letters. There's nothing else that I can put in this list that uses R, G, or B as a group of 2 that would be different than what I already have up here. So that's what the permutations does for you. It gets you all the different possible listings. Dividing by the grouping number factorial gets rid of all of the doubles, all of the repeats. Okay, how does it do that? Well, here's why. We're taking things 2 at a time. Okay, so when you take 2 factorial, you get 2. Okay, so that means for red, green, there are simply 2 different ways for me to write red, green. Okay, that's what that's what the grouping number factorial tells you. There are 2 different ways to write red, green. I can write red, green, or I can write green, red. There's only 2 different ways. So in other words, half of my numbers are going to be repeats. Half of them will be countable. They'll be favorable. They'll be things that count. So by taking the permutations and dividing them by 2, or in other words, cutting out half of them, I now have what's left over, or the answer is all of the uniques, all of the groupings that count for a combination. It gets rid of all the repeats. So I had red, green, and green, red. I have blue, green, and green, blue, but one of these doesn't count. Half of them don't count. Okay? And then I had blue, red. Yep. And I have blue, red, and red, blue. But again, there's only 2 different ways to write it, but half of them don't count. Okay? So that's a small example where your grouping number is 2. I'm now going to use a bigger example. I'm going to use a bigger grouping number. Okay? And now the grouping number is 3. So now I've got 5 letters being put into groups of 3. I'm going to take the first 3 letters. Because they're in a group of 3, if I take that 3 and I factorial it, or in other words, I permutate it, okay, I'm going to do 3 times 2 times 1. I'm going to find all the different possible ways. When I do 3 times 2 times 1, which is what this is telling me to do, what that is doing is that answer I get right there, that 6 tells me there are 6 different ways to arrange a group of 3. There are only 6 possible different ways to arrange a group of 3. Okay? So I can take the letters R, G, and B and arrange them 6 different ways. That's what that's telling me. That's what this is telling me. There are 6 different ways to arrange a group of 3. So if I take RGB, I can also write it RBG. I can write it as GRB. I can write it as GBR. I can write it as BRG or BGR. Those are all the different possible ways I can write this group of 3. I can only write any group of 3 in the world. I can only write it 6 different ways. However, only one of the 6 counts in a combination. So in other words, out of all the possible outcomes, so when you find the permutations and you find all of the outcomes, okay, which would be, if you find all the permutations, which is 5 times 4 times 3, so there's 60 different possible groupings of 3 for these 5 letters, but only 1/6 of those count. Only 1/6 of those count. Okay? Because for every single group of 3 that does count, there are 5 others just like it that don't count. Here's the one that does count. Here's the 5 that don't. So out of all of the possible 60 outcomes for RGBYZ to be put into groups of 3, 1/6 of them count and 5/6 of them don't count. For every single group of 3 I come up with these 5 letters, I will be able to come up with 6 options, but only 1 will count. And so if you take all the possible outcomes and divide it by that 6, which is what this gets you. Remember, this is that 3 times 2 times 1. This is telling me that there are 6 possible outcomes for every group of 3, but only 1 of them counts. And so if I take the total number of outcomes and divide it by 6, what that's going to get me, okay, in this case the total number of outcomes is 60. So if I take that 60 and divide it by 6, what that's doing is that's finding me 1/6 of 60. It's finding me 1/6 of the total outcome, because remember, only 1/6 of the outcomes actually count towards a combination, because the other 5/6 make up repeats. And remember, repeats don't count. All 6 of these different outcomes here, they're all the same thing in a combination, because in a combination, order doesn't matter. It's very similar to the commutative property of multiplication and addition. R times G times B is the same thing as R times B times G. Same thing as G times B times R. They're all the same thing. So you can only count one of them. Okay? So again, the bottom number, when you take the number that represents your grouping, so I'm doing groups of 3, and you factorial it, what that's really doing is it's finding all the possible outcomes to arrange those 3 numbers. So when you have a group of 3, there are 6 different ways to arrange any group of 3. The permutations on top get you all of the total outcomes. Okay, all the possible outcomes to arrange all the groups of 3. There are 60 groups of 3 that you can make with RGBYZ. With 5 things, you can make 60 different groups of 3. However, out of those 60 groups of 3, only 1/6 of them count, because the other 5/6, as you see here, are going to be repeats. Okay? And the reason why I didn't do other groups of 3 for RGBYZ is because I don't need to. I could do GBY, and again I would have 6 different things up here, but only one of them would count. I could do BYZ, but again I would have 6 groupings, but only one group would count, because all 6 groupings would have the letters B, Y, and Z in them. So there's no point in me doing all 60 different outcomes and then crossing off all of the different repeats when I can just do this. The permutations, the permutations of 5 times 4 times 3 divided by the grouping number factorial. Because remember, when you take that grouping number and you factorial it, that tells you how many different possible ways you can arrange a group of 3. And in a combination, you can take a group of 3 and arrange it in as many ways as you want. But as long as the same letters are in there, only one of them counts. Okay? So just real quick to show you what the combination looks like done out. If you have combination 5-3, you're going to permutate the 5 students taking 3 at a time, or the 5 colors taking 3 at a time, whatever it is. You're going to permutate it. 5 times 4 times 3. And that's going to get you all the total possible outcomes. You're then going to take the grouping number and you're going to factorial it. So you're going to go all the way down until you multiply by 1. You're going to go 3, 2, 1, or 4, 3, 2, 1, 5, 4, 3, 2, 1. And that's basically going to get you all the different possible combinations, all the different possible outcomes for a group of 3. Okay, because the first number in a group of 3, you have 3 choices. The second number, you've only got 2 choices left. And the third number, you've only got 1 choice left. So like if I had R, G, and B, and I had to figure out all the different possible combinations for that, or all the different outcomes for that, I mean, okay, the first color that I choose has 3 options. After that, I've only got 2 options left because the first color has already been used. After that, I've only got 1 color left. Multiply them together, you get all the different possible combinations or outcomes for a group of 3. Multiply it out, you get 60 on top, 6 on bottom. And you find out that there are 10 different combinations for 5 things taken 3 at a time. I know that might be a lot to kind of try and absorb, but again, if you pause the video, take some good notes. At this point, definitely, if you're confused, ask me for some help. Sometimes just sitting down and walking through it with me in person makes a difference. For some reason it just clicks, even though I explain things the same way. Sometimes you just need to hear it and see it in person. So if you need any help at all, let me know, but hopefully you understood this. If you don't, please let me know. I do need to revise these videos. This is a concept I have not yet. This is my first time explaining this concept out loud. So hopefully it came across clearly enough. I know I repeated myself a lot, and I apologize for that, but I want to make sure I get the concept home. And I know for some of us, we need to hear something multiple times before it settles in. So tune in for the next video, Chapter 12, Section 10.